Hi, this is a supplement to the Executive Black Belt class, week 3. We're going to be talking about, very briefly, about calculating process sigma. And so let's get to it. Process sigma, now that we understand what capability is and that baselining always has those two parts of stability, evaluating stability and evaluating capability. Stability being the voice of the process, capability being the voice of the customer. And we usually think of that as stability being looked at by a control chart, so we're seeing something, how it evolves over time. Is it remaining stable or is it moving all around? That's the voice of the process, but we also want to look at capability, which is essentially the percent good, right? The percentage of time or the proportion of times that we actually meet the customer expectations. And with a control chart, the data determines the limits on the process. The data determines it. But in capability analysis, it's the customer that determines it. Now, it could be, instead of the customer, it could be management. It could be a management goal. Or it certainly could be, you can think of it as kind of coming down from Mount Olympus. Thou shalt have a cycle time of less than 20 minutes in order to do this particular task. That's not coming from the process data. So anyway, process sigma is yet another way of looking at process capability. I think if we look at it that way, we'll be in good shape. Now, it has some good points and some bad points, and I think we'll touch upon those as we go through. So let's get to it. Here's certainly where you mostly use your calculations for process sigma. It's in baselining the process, but you also can use it at the end to show the improvement. And again, it's a capability. And what I've done here at the bottom, I just wanted to talk about that for a moment. It does one of its really good things. I mean, I gave a very firm opinion, I think, when we were doing the capability, but I have a very strong preference for simply communicating, what percent bad is the process, or what percent of the stuff are we really getting right. DPMO is another way of expressing that, but sometimes when we get to say 99% good, it's very, very hard for people to think that 1% is not good enough. And mentally, just a lot of people have a block. We know that in a lot of cases we do need to get people to do better than that 99% because there's a ton of money, or there's a ton of customer goodwill, or there's a ton of additional customer value that we can get out of not messing up on it 1%. And so sometimes DPMO can give us a shock. There's a shock value of saying, oh yeah, well we're only making 1% error, but we're doing this millions of times. That means we're making thousands of errors, and sometimes that has a lot of merit to doing that. So process sigma can be beneficial. All right, let's just walk through how to calculate it. And for this example, what I've got is I've got a three-step process, and although at first blush you might say there's no process that's 3 steps, we can think of sometimes abstracting processes at a high level so that they have 3 or 4 steps, and very often that's a good way of thinking about it, particularly for communicating. So this could be any sort of summarized process. Let's take a look at a few of them. Let's take a look at a few of them. There we go. All right. So let's take a look at a few of these processes. So we could think of it as a sales process. And if we were talking about a sales process, perhaps step 1 would be prospecting and qualifying. That might be step 1. And step 2 might be our information gathering, and step 3 might be presenting and closing. So we can think of those as step 1, 2, and 3. Okay. If we're talking about in a warehouse, maybe step 1 could be picking a pallet. Step 2 might be staging that pallet onto a loading dock, and step 3 might be actually loading it into the truck to get it ready to go. And if we're in a hospital, maybe step 1 is admitting a patient. Step 2 is, that's a big step too, but delivery of the care to that patient. Maybe step 3 is discharge. Okay, so again, we can abstract these things at a fairly high level as step 1, step 2, step 3 process. And in this case, I just want to notice sort of what is the, I'm going to call it the unit. And that's the entity that's kind of going through these processes. Well, the sales one is a little bit difficult, but maybe it's a potential customer that's going through this one. That one's probably the most difficult to think about the entity. For warehouse, it's maybe a pallet of goods. I never remember whether it's 2 L's or 2 T's. We'll spell it like that. A hospital, it would be a patient, and so forth. In many administrative processes, it's a transaction, or it used to be a piece of paper, but now it's an electronic piece of paper, if you will. So there's all sorts of things like that we can think about. And anyway, that's where we are. So it could be any one of those. All right. So now let's get back to our presentation, and yes. So process sigma now. If we're looking at it, oh, here's where I was. That's right. So let's look at this from the point of view of let's take the medical process. So step 1 you can think of as admitting. So I've got 1,000. I go out and I collect some data, and I say I collect some data on 1,000 patients coming through, and I determine through definition there are 15 points of failure at the admitting. There's 24 points of potential failure in the care delivery, and there's 8 potential points of failure at the discharge. Okay? So obviously this is more complicated, probably grossly underestimates the number of chances of error there, but that'll work for the example. Okay, and then I will note as I'm collecting this data that of the 1,000 patients that went through, there were 29 noted errors in process step 1, 500 in process step 2, 200 in process step 3, for a total of 729 errors in 1,000 patients coming through. Each patient had a total of 48 chances for making an error. So when we're calculating process sigma, the first thing we do is we have to collect some data, and we have to determine how many opportunities per unit at each process step that's going through. Okay? We then calculate the defects per million opportunities, which is essentially just a million times the number of defects divided by the total number of opportunities, which I can get by multiplying the number of units times the number of opportunities. So just as a, let me see if I can get my handy-dandy pen out again. Seem to be having a little bit of problems with that. Okay, so if I take a look at that, let me see if I can raise the bar again. No, it doesn't like that. Okay, well. Okay, so yeah, so let me just write right on the page here. So in this case, I've got 729 errors, so that would be the defect right there. That's a total, 729, divided by the total number of opportunities, which is 48 times 1,000. See that? Which is 729 divided by 48,000. All right, so that's essentially what goes in the denominator over here, and that's just adding up all those things right there. All right, and that calculates out what our DPMO is. Now I'll get back to the regularly scheduled program. Sorry about that. Okay, at this point we're going to use a table lookup to see what our process sigma is by looking at the defects per million opportunities. Okay, we'll get to that in just a moment, but it all starts with DPMO. So this one is 15,187. That means that this particular process is producing 15,000 errors for every million opportunities that we have. Another way of simply looking at it, and I kind of like this way, is to look at just the defects per unit that we're getting. So defects per unit is just 729 divided by 1,000. And in either case, we can go into our sigma level template, or sigma level calculator template, which I'm going to show you in just a moment, and we're going to calculate this out. So let's just kind of write it all down, and we can see by entering it in. In this case, we have 1,000 units. The total number of defects we had was 729, right? And the defect opportunities per unit was 48. And there it is. It comes out with 15,188 and a sigma level of 3.7. So that's what we get when we're looking at that particular sigma level. Okay, just a moment here. Be right with you. Okay. So the second thing I want to notice is that another way we can simply write it is to just say we have one sorry about that. We have one unit, and for each unit we make 0.729 errors. In other words, that we enter in the defects per unit, and we enter in that n as a single unit. Remember, there were 729 errors in 1,000 units that we had. So that's just a percentage of the total. It gives you the same answer in either case. I just wanted to show you that. It's no big deal. That's there. So so that's it. I mean, it's really as simple as that in terms of calculating the sigma level. The hard part is, of course, determining realistically how many defects there are, how many opportunities there are per unit in each of the process steps. Now, I want to also show you. We might want to go through and say, well, we'll do this at the end. Let me get back to the PowerPoint or my slideshow. And there we go. I mean, we got the same answers that were in there. I just want to show you that this is in your calculator. All right. Now, I also want to demonstrate one other thing. Now, suppose we're looking at, let's do an example here. Suppose we're looking at invoice collection times, and we have a specification of 20 days, and we had a, suppose that 94% of the time we failed to meet the spec. Define what my process sigma is for this process. So let's do this. And here we've got we need to define a defect is any invoice that's aged above 20 days. So any invoice that ages above 20 days, that's counted as a defect for this. We're also going to define that there's only one opportunity per invoice. Now, what I can tell you is that's generally speaking a good way of looking at it, because it lets you know what the customer is actually seeing. One opportunity per unit, you got one chance to really get it right. To me, I think that's a nice way of looking at it, and we'll actually explore that just a small amount before we move on. All right, so let's take a look at what that would be, and we can just type that into our sigma level calculator. So here I've got, let me just do it as one unit. Whoops. Or one, it was 25.4%. Was that it? 25.94%, I think it was. So for every 100, that means for every 100, you're making 25.94 errors, and there's one opportunity per unit. That's a sigma level of 2.15, which makes sense. I mean, if it's 25% problem out of every million, you're making essentially, 250,000 errors. So that translates to a sigma level of 2.15. And in fact, that's the answer that we have on slide number 139. Now, one would ask the question, is a process sigma level of 2.15, is that more understandable to people than if you just said, well, we have a process where 25.9% of the time it doesn't meet the spec? I would claim that no, that's not more understandable. And so in a case like this, we would probably not want to use sigma level to communicate that. It's, again, remember, it really comes in helpful or handy when you've got a very low percentage of errors. and you're having trouble motivating people to get past that. So that's basically it. However, I did want to show you one other thing. Suppose instead we define 10 opportunities per unit. And we said, oh, you know what, for this invoice, there's actually 10 different chances we could have for an error. I just want to show you what would happen. You know, say it was 4 steps in the process. In this case, it's 4 steps. We had 3 before. And we added up the number of opportunities per unit, and we still counted it the same way. Well, what would happen? Well, if we just plugged in 10 opportunities per unit, look what happened to our sigma level. It went up. It got better. And we need to be careful and cognizant of this. We shouldn't be trying to paint a better picture of our process than we should be. Or, I mean, than the process is actually giving to the customer. So my advice would generally be to go with the 1 opportunity per unit as your quick calculation of the sigma level. And you know, one way of thinking about this, one way I like to think about this, let me go to my chalkboard here. Go to my chalkboard, and I'm going to think about if you guys are football fans or something like this. But if you think about it, you know, here's a football kicker. Here's the football leaving the kicker's thing. Let me put his helmet on. Kind of looks like a baseball player or a duck or something. Oh my goodness! And let's suppose that this football kicker kicked 10 footballs, and he got in 7, and he missed 4, or he missed 3. I know how to add to 10. Yes, 7 out of 10. So, I mean, we might say this person's success rate or error rate. Let's just say the error rate is equal to 30%. And I think as a fan of football, that would make a lot of sense to us. But think about it. If we were trying to define the number of chances for errors, we might say, well, it could be, there could be a problem with crowd noise, or it could be a bad snap, or it could be a divot in the field, or bad playing conditions like that, or it could be a bad hold, and so forth. And if we do something like that, now let's suppose we just defined 4 chances for error per kick, or 4 opportunities. Let's use the opportunity language here. 4 opportunity per kick, opportunities per kick. And if we're calculating our DPMO and all that, all of a sudden our error rate starts to look better. So our defects, now we used to have a 3 out of 10 problem, but now if we look at our defects per opportunity, now we've got 3 divided by 10 times 4. So now it's 3 divided by 40. And the percentage is looking better all of a sudden. So the person's error rate went down, so their sigma level is going to go up. And the real question is, well, from the crowd's perspective and from the customer's perspective here, I don't care how many opportunities you want to define about bad snaps, or ball took a bad hop, or the crowd noise was bothering me, or the weather. I forgot about the weather. I still have a 3 out of 10 problem. I don't have a 3 out of 40, or 3 out of 50, or 3 out of 60, or a 3 out of 100. So just be cognizant of that when you're defining all these opportunities, one easy way to do this is to, if you're gonna benchmark yourself, if you're gonna baseline yourself, is to simply use 1 opportunity per unit. Simply do that. And I think you'll get better results that way. There's no chances to miscommunicate that way, or that minimizes the chances to miscommunicate. Okay. Let's look at our final example. And on slide 141, we're just really talking about that. The real pro is that there's a lot of shock value with this. We've said that enough. And the cons are it can create a possibility for playing games with numbers. So let me just say it to you, don't you play games with numbers. I don't play games with numbers. Most people play games with numbers unknowingly, if at all. Now, if you're going to define multiple opportunities, here's how you need to be calculating them, not simply one error per unit. So that was a problem with our field goal. It didn't matter if there were multiple errors, it was still counted as one miss. Sometimes it does make sense to say, let's count up all the total errors that happen. So, for example, in this one, if we're just looking at one piece of data, we'd obviously need to look at many more units. But here, there were 2 opportunities per unit on process step 1, 3 per unit on process step 2, 4 per unit on process step 3, and 1 per unit on process step 4 equals 10 opportunities per unit, but there were 3 errors, not simply 1, and we want to note that. So that's another reasonable way to do it. It's obviously more complex than doing just counting, one chance per unit that's going through. Here there's many more chances, but we're also allowing for the possibility that there are multiple errors on a single unit. Okay, before we go on, I wanted to also show you a couple more things in the sigma level calc, and just to give you an idea of what various sigma levels are, we can kind of play games around this. So if we had, let me just do, let's see, what if we had 1,000,000 units? What would be a level that's 6 sigma? Just to give you an idea, that's 1,000,000 units. It turns out that a 6 sigma process, if we put in 4 errors, that's a 5.9 sigma process, and if we put in 3 errors, that's a 6.03 process. So it's somewhere between 3 and 4. It turns out to be about 3.4. About 3.4 defects per million opportunity will give us a sigma level of 6. Which is pretty darn impressive. And if we wanted to, one thing I would encourage you to do is to kind of play around with these things and see, well, what would be a level 5 process or a sigma level a sigma level of 5 process. And you can play games with, well, is it 100? It's less, it's less. It's greater than 100 errors. So is it 150 errors? Oh, no, it's greater than that. Is it 200 errors? No, it's a little greater than that. Is it 210? And so forth. You can play that. But one thing you should be noticing is that it's a pretty big factor, right? Because if we're talking about going 3.4 sigma level 3.4 defects per million opportunities gives us a 6 level or a process sigma level of 6, and only about 250 or so errors, we're getting something that's about a level 5 process, sigma level 5 process. Well, that's a big difference between those. So think about that. Moving from a 5 sigma process to a 6 sigma process is like almost a factor of shrinking it by about 100. So that's huge. And the same thing goes for other sigma levels too. So to get to a sigma level of say 4, about 1,000 per. I'm sorry, quite a bit more. Yeah, what was it? About 3,000, something like that. Yeah, there we go. And it's even less than that. I've made actually a table of this. You can tell I don't put all that much stock in sigma level because, quite frankly, I find it harder to translate. But anyway, here's a sigma level translator that goes between percent good and the level of the sigma level, and you can see that you can actually have a negative sigma level if you get below, say, 10% sigma or 10% good. You can actually get a negative level sigma. But here we are up at about 1 sigma. That's about 30% good. is a 1 sigma process. At a 2 sigma process, we're talking about maybe 65% good. 3 sigma process is about 94% good. And here we are at 4 sigma process where we're really hitting that 99 or slightly above there. Let me now also kind of expand this, and we'll go just the scale. We'll look at between, say, 95 and 100. And now we'll just look at it above 3. So you can see here's our 3 sigma process. Whoops, I didn't put in enough. There we go. There's our 3 sigma process. It's less than 95%. Here's our 4. It's about 95.5%. And here's our 5. Again, we're kind of losing it in the mist. So let's expand this out again. I may say 99, and now I'll put another decimal point there. So there's our 4 sigma process at, I guess I need another, I guess I need more decimal points out there to even see it. So you can see that it's really, we're really hitting that top. If we actually look at the table of sigma levels, that'll give us that. Here's our percent good. Here's the sigma level for, like, a sigma level 4 is about somewhere between 99% and 99.5. Level 5 sigma is like 99.99, 99.98 percent good. So that's pretty awesome. And then a 6 sigma process is like 99.9999% good. So it's really pushing the level. Now, needless to say, not every process needs to be at that level. So at the bottom of it, that's another thing that sigma level can kind of obscure. But if it is important to get it better and better and better and better and as good as it can be, like, for example, a pharmacy process, you just don't want to have drug mix-ups, or crashing a plane, you simply don't want to have thousands of errors per million flights. You have to do a lot better. You want to push that, and sigma level would be a great way of looking at the capability. Well, I hope you took away you were able to take away a few things here, and I hope that you got a flavor for how we do sigma level calculations and all the rest of that, the good and the bad and the ugly of calculating process sigma. Thank you.